Yeah, as mentioned, my name is Haiku Sky, and it's definitely an honor to be here. The title of my presentation today is Enabling Renewable Energy Planning Through Data Visualization. And how I'm going to discuss this topic is really going to be through demonstration of an application that's we've developed over the past 3 years. This application is called the State and Local Planning for Energy, or SLOPE application. So SLOPE enables renewable energy planning, and it does so by providing a wide array of data sets in a central, accessible location, and allows users to view spatial and temporal data. So I'll be providing a brief overview in the next few slides, and then I'll provide a demo of the SLOPE application itself. Okay, so to further introduce myself, I am a product portfolio manager within the Geospatial Data Science group at the National Renewable Energy Lab, or NREL, which is located in Golden, Colorado. My role entails overseeing the long-term strategy, design, development, and iteration of several dozen geospatially focused applications, which obviously includes the SLOPE application. Okay, so brief overview of SLOPE before we actually see it in action. So as more state and local governments begin to develop comprehensive energy plans, the adoption of efficient, sustainable, renewable energy technologies has become a strong focal point of many planning processes. And although extensive resources and data exist to identify opportunities to deploy these technologies, the dispersed, unintegrated, and sometimes inaccessible nature of this data makes it really difficult for state, county, and city governments to easily consider, compare, or fully capture the value of this information. So this is where SLOPE comes in. The primary purpose of SLOPE has been to integrate data related to energy efficiency, renewable energy, and sustainable transportation. And subsequently, SLOPE delivers these data sets in an easily accessible web-based platform, and this enables data-driven energy planning. So by accomplishing these two primary purposes, SLOPE ultimately contributes to a much larger goal of supporting the transition to a 100% clean energy economy. And as mentioned, we've worked on the SLOPE application that's gone through iterative development over the past 3 years since its initial conception. And SLOPE has been a collaboration between 9 of the U.S. Department of Energy offices, as well as obviously the National Renewable Energy Lab. So as mentioned, SLOPE provides a singular source, completely public-facing in a web-based application for a lot of data. And ultimately, this allows users the ability to access and visualize this data. And this data comes from 20 different sources, and it spans 42 individual data sets across 6 categories. These 6 categories include, as listed, energy consumption, energy efficiency, energy generation, as well as cost of energy, demographics, and information on commercial buildings. And the spatial resolution of the data sets, it varies a bit by data category and the source. However, it collectively spans national, state, county, and city levels. My apologies, the auto advance keeps clicking on. And similarly, the data sets vary in regard to temporal resolution. So they cover a time frame from single years all the way out to multi-decade projections up to 2050. And as mentioned, the data is all publicly accessible, so it's available for download, and sources of each data can be viewed in the About page on SLOPE, as I'll showcase in just a minute. Okay, so let's dig into the live demo of the web application. So before I do so, if anyone would like to actually go to the application at this point or any point in the future, I've listed the URL below. It's maps.nrel.gov/slope. So please have a look, and if you feel strongly about anything, love it or even hate it, we do have a feedback tab. Feedback is tremendously useful. So if anyone has any thoughts or suggestions, more than happy to hear them. Okay, so let's have a look at slope. All right, so as mentioned, this the slope application is built, it's designed for planners, and a lot of times energy planners may not actually have a whole lot of information or background or knowledge, of course, on geospatial data. So one of the key considerations was make it simple, make it useful, of course, but really create a almost minimalistic application that was easy to read, easy to view, easy to navigate. However, that allows complex data to be accessed and then be analyzed in a desktop geospatial application or GIS application as needed. So to orient users on the home page, I won't spend too much time here, but just gives a quick overview of what slope is, how you use it. We do have authentication, which allows users to create an account. And we do have a quick tutorial as well on the application. Let's touch on the About page real quick. So the About page gives a little bit deeper information. But I think most relevant is really the two data FAQs. So if anyone's interested, please have a look here. As mentioned, there's a lot of different data sets. So this provides a list of everything that's available on slope, as well as the specific sources of data that are showcased. All right, so the main functional purpose of slope, and I realize this map is ridiculously large because I have a large external monitor. That's yeah, the bulk of what you'll actually do in slope is in the Data Viewer tab. And so what we have right up top is quick overview of that application, of that data set that's by default showcased. And again, we do reference where you can actually access the source information and any other relevant information. So on the map view itself, you can immediately see, simple map view, map legends, and then for this specific data set, which is listed up top, personally owned light duty vehicle, miles traveled. So for this data set, once we start interacting with the map, a few more things will happen. But just before we do that, open up the layer database. This is where you can access different data sets. Again, these are all in coordination with what's actually listed in terms of the data and the data sources. Okay, so if we stay on vehicle miles traveled, go ahead and click on Colorado, where I am located. You can see it now provides a little bit more information. So at this spatial scale on the state level, it'll provide aggregate information for this data sets, and here it gives a really quick view just in a graph chart format of essentially the different categories based off this given year. Now this data set, as mentioned, not all data sets have multi-year temporal projections, but this one does. So as you go through, you can see things change. Not a whole lot's happening since I'm zoomed into Colorado. It's going to be a pretty light change between years. But again, if you go to the county view and zoom in, you can see aggregate data from there. All right, let's look at something maybe a little bit more fun to look at. So let's look at solar panels or photovoltaics. And as the energy industry differentiates between solar panels and then concentrated solar So let's go ahead and look at residential. So if you want to have solar panels on your house, this is that category. So from here, the graph changes. You have the ability to look at different categories. And at this spatial extent, it also has state and county. So if you go back out to state, kind of look at the whole nation, look at different state. Texas, for example, great solar resource potential here. And you can look at information pertaining here. And for this data set, it's only single year data, so not a whole lot of projection there. Lastly, if we look at wind data, again, very similar. Wind resource data is very high in Midwest region of the US. So you can browse at your heart's content through that. And then lastly, we do have data for Alaska and Hawaii as well, even though it appears as the continental US. We have these quick links, so you can actually zoom up to Alaska, which we do not have data for this specific data set for. However, going down to Hawaii, we don't have data for this data set either for Hawaii. Okay, so I think that's closing it in on my time. I guess just to leave one last feature of Slope is the story mode. So we have had a handful of cities actually use Slope to implement a lot of the data that we provide into some of their planning purposes. So the first city, which is in Milwaukee, Wisconsin, they want to partner with us to actually provide an interactive story of their experience. And so going through, we basically included kind of snapshots, views of some of the data sets that were relevant to some of their planning. And scrolling through, it's kind of like a Esri story map in a little bit of way, shape, and form. But as you scroll through, you can read about their specific use case, what they found useful to actually adjust and review. All right, I think I am at my time, and I would love to answer any questions if they come up. So, Elena, I'll hand it back to you.
Thank you, Haiku, and thank you so much for that demo. You could really see the time that was taken to make it a good user experience and a really easy to use tool, but also getting a lot of data in there for the best insights possible. So we do have time for a couple of questions, and we'll start with this one from the Q&A chat. How do you handle data management? Do you use big data tools for this project?
That's a great question. So data management, so as mentioned, I'm part of the geospatial data science group. So my immediate team, about 5 of us, we predominantly focus on application developments, but the rest of the team, which consists total of about 22 people, it's heavy focus on analysis, modeling, and obviously management. So data management, it's not a single answer just because the lab has a tremendous amount of data. So we do have a supercomputer for a lot of our processing. A lot of our management is conducted directly by our group, and then we collaborate with our IT departments a lot, and everything between on-premises servers, a lot of cloud-based focus, and then at least a few other techniques that I'm probably forgetting at this point. So I guess if whoever asked that question, if they want more details, feel free to reach out and I can provide a more comprehensive answer.
Great, thank you. Sounds like there's a lot of different hands that touch the data management process here as you're working with a ton of data. And then in terms of use cases, so by having this data more accessible, have there been any areas identified in the US that are surprisingly good locations to host a renewable energy project or facility that might have been overlooked otherwise?
Yeah, and again, that's a great question. Not a simple answer, but just because the scope of what we do is so large. But we being the lab and then our immediate group, we hear a lot of feedback about just providing a new dimension of data in an accessible format has essentially allowed industry, researchers, whatnot, to identify not just new areas, but just kind of like new slices of areas, or really to ways to be much more efficient in terms of just extracting a little bit more energy out of any specific resource. So again, great question. Yeah, complex answer. So feel free to reach out and I'd be happy to chat more.
Perfect. I think that is all the time we have for questions.